Hello students, today we are going to learn more about the nomenclature of organic compounds. Today we'll be seeing the IUPAC nomenclature of organic compounds with functional groups. Functional groups are atoms or group of atoms which characterize the chemical properties of organic compounds. Now, here we are following the same different steps involved in the IUPAC naming. First thing, find out the longest carbon chain and number it in such a way so as to give minimum number for the carbon bearing the functional group. In case of many functional groups, the order of decreasing priority of the different functional groups is given by carboxylic acid, the greatest, followed by sulfonic acid, ester, acid chloride, amide, cyanide, aldehyde, ketones, alcohols, amines, alkene and alkyne. So the code word will be ACIAC, alk, alamine, alk, alkyne. Various groups like R with the formula CnH2n plus 1 will be considered as alkyl group. C6H5 is called phenyl group. OH coming as the substituent will be called as hydroxy. X stands for halogens, fluorine, chlorine, bromine, iodine. That will be named as halo or fluoro, chloro, bromo, iodo. NO2 stands for nitro and OR stands for alkoxy group. These groups, when attached to the longest chain, they are considered as the substituents. Taking into consideration all these factors, we are going to name the different compounds. So kindly remember the order: ACIAC, alk, alamine, alk, alkyne. We shall start numbering the different compounds and try to name it. First compound has Br and a double bond. Now what is the priority that you have to give? According to the priority order, we find that alkenes must be given priority. So the numbering should start from right to left. So the carbon chain will be numbered as 1, 2, 3. How many carbons are there? 3 carbons are there. So it is a derivative of propane. But we have a double bond. So where is the position of the double bond? It is in between the first and the second carbon. So it should be propene. Position also has to be mentioned. So it is prop1ene. Where is the position of bromine? It is on the third carbon. So what will be the naming of the compound? Compound will be 3. Begin with a capital letter. Bromo. Prop 1 ene. 3 bromo prop 1 ene. Second compound has the structure OH, CH2 5 times, C double bond O, CH3. Now which are the substituents here? We have an OH group as well as a CO group. Now we have to decide which is the primary functional group or the principal functional group. Here, on considering the priority order, you find that ketones come first compared to that of alcohols. So ketones must be given priority. So the numbering shall start from right towards left. 1, 2, 3, 4, 5, 6, 7. That means this is a 7 carbon chain. So 7 carbons are present in the chain means it is a derivative of heptane. The position of OH group is on the 7th carbon, and this is a ketone positioned at second position. So if it is a ketone, the name should end with ONE. Position is second. So what will be the name of the compound? The naming will go like this. It is 7-hydroxy heptane 2 on. So the naming will be 7-hydroxy heptane 2 on. On examining the third structure, we have two functional groups here. One is COOH, the other one is CO group. You know that the primary priority should be given to carboxylic acid. So numbering shall start from the right side. 1, 2, 3, 4, 5, 6. That means it is a 6 carbon chain. It is a derivative of hexane. So the naming will go like this. So it is a carboxylic acid. It is a hexanoic acid, but it has a ketone group at the 5th position. The principal functional group taken here is COOH. So the connective group here or the substituent becomes oxygen. So the name of the compound will be 5-oxohexanoic acid. Because COOH is in the first position, we needn't specify it as 1-oic acid. So the name is 5-oxohexanoic acid. Coming to the next compound. Here on examining we have a double bond as well as a triple bond. Double bonds are 2 in number, whereas triple bond only 1 is there. When we consider the priority order, we find alkenes are given more priority than the alkynes. So alkynes become the substituent. So the numbering shall start from right to left. 1, 2, 3, 4, 5, 6. It is a derivative of hexane, but we have double bonds at the first position as well as the third position, and the 5th position is occupied by a triple bond. So the naming will be hexa 1, 3 diene 5 YNE. Hexa 1,3 diene 5 YNE. On considering the next compound, we have the substituents Cl and NO2. Here, Cl is more electronegative, so it is given priority. So this will be 1, 2, 3, 4, 5, 6. This ring is known as benzene ring. So the substituents that are present at first, second and fourth position. We name this compound as a derivative of chlorobenzene because chlorine is given more preference. So this compound will be 2,4-dinitro chlorobenzene. Hope it is clear. 2,4-dinitro-chlorobenzene. Now a few examples in which we are able to derive the structures for the compound. So first compound has the name 2-chloro-4-methyl-pentane. So how many carbons are present in the compound? There are 5 carbon atoms. So first write 1, 2, 3, 4, 5 carbons. Number it. How many numbers are there? 1, 2, 3, 4, 5. Second position we have chlorine group. Fourth position we have methyl group. The rest fill up hydrogens. So we have one bond here. The rest will be 3 hydrogens. 1, 2, 3. So 1 hydrogen. 1, 2. So 2 hydrogens. 1, 2, 3. 1 hydrogen. Last one has 3 hydrogens. So this is the compound 2-chloro-4-methyl-pentane. Next compound, but-3-ine-1-ol. What do you understand by but? But means there are 4 carbon atoms. So the carbon chain will contain total of 4 carbon atoms. 1, 2, 3, 4. First position we give OH group. So number it 1, 2, 3, 4. First position we are giving OH group. And third position you have triple bond. YNE means triple bond. So triple bond exists between the third and the fourth position. So now distribute the hydrogens accordingly. So how many bonds are here? We have 2 bonds. So the rest will be filled with 2 hydrogens. 1, 2, 2 hydrogens. 1, 2, 3, 4. So no need of extra hydrogens. What about this case? 1, 2, 3. So 1 hydrogen. The structure is OH, CH2, CH2, single bond C, triple bond CH. Coming to the next compound, 2-chlorohexane. How many carbons? There are 6 carbon atoms. 1, 2, 3, 4, 5, 6. Number it. Start numbering from left to right. 1, 2, 3, 4, 5, 6. You can very well number it from right to left also. Accordingly, the position of the functional group or the position of the substituent will keep on changing. So here we have second position, chlorine atom is present and the rest we have to fill it with hydrogens. How many hydrogens here? You have 3 hydrogens. 1, 2, 3. So 1 hydrogen. 1, 2. Hydrogen H2. 1, 2. H2. 1, 2. H2. And the last one carries only 1 bond. So that means CH3. So this is the structure of 2-chlorohexane. Coming to the next compound. It is 3-nitrocyclohexene. Hexene means it is cyclohexene. Means it is a hexagon with a double bond. That is why it is cyclohexene. If it is cyclohexene, the numbering should start from the double bond. So number should be 1, 2, 3, 4, 5, 6. And third position we have the nitro group. So the nitro group is attached on the third position. So this is the structure of 3-nitro cyclohexene. The last compound taken is cyclohex 2-ene 1-ol. Cyclohexene means it is a cyclic structure. So this is cyclohexane. Now we have to convert it into ol. 1-ol means first position we have OH group. This is first position. Second, third, fourth, fifth, sixth. And now we have second position we have an ene, that means a double bond. So second position means the double bond is in between second and the third position. So the structure will be like this. Hope it is clear. Today we have briefly discussed the method of naming the different compounds. Hope you have an understanding of nomenclature now. Thank you.